Okay, thank you everyone for coming to the SOS seminar. And sorry, we're experiencing some technical challenges. So thank you for your patience, and also thank you to Deniz. So our speaker today is Deniz Karakoc from the School of Computing and Augmented Intelligence. So she'll talk to us about her work. Welcome.
Thank you so much for the invite. I really appreciate the opportunity to present my work. I'm Deniz. I started last year at ASU. I usually work on some interdisciplinary approach to model food supply chains across spatial scales to come up with strategies to enhance their equity, sustainability, and resilience. So today I will present you some of my work I did for the food supply chains in the US, and I will briefly mention other studies that are going on at the global scale as well. Okay. All right. So I'm sure you all are aware that food supply chains are essential for humanity, right? And they consist of three major steps along the supply chain: production, processing, and consumption of essential goods. But along every step, we have a distribution network that connects production to processing, processing to consumption, sometimes even production directly to consumption, right? And this distribution network is usually accompanies multimodal and large-scale infrastructure networks, transportation networks. And most of my work focuses on the distribution aspect of food supply chains and how can we model the distribution and understand the current characteristics so that we can enhance the resilience, sustainability, and equity of it. All right. So for resilient agri-food transportation in the US, these are the three major research questions that I tried to answer previously. And the first one was, what are the spatial trends through time for agri-food transportation networks? To answer that question, we developed a temporal food flows model between the US counties. This was a really data-driven study. Actually, US government does a really good job in terms of collecting data. So they have the freight analysis framework data. They were publishing it once every 5 years, but recently they're publishing it annually. It records the different food commodity movements on different transportation infrastructure between FAF regions in the United States. So the government divides states into their more urban versus rural regions. For example, if you think about Arizona, it's going to be Phoenix, and then it's going to be Tucson, and then the rest of Arizona are three FAF regions we will have. So from around 50 states, we come up with 132 FAF regions in the US, and the government records how much food and which type moves along which transportation infrastructure between them. But we were thinking, okay, this is a great data, but it's not that detailed spatial resolution, right? If I'm thinking about local level decision making for social and environmental well-being, food security, or more resilient food systems, less food waste, I'm not going to be able to say, looking at the entire Arizona, I can make really targeted policies regarding just Maricopa, right? So we were thinking we need more detailed information. So how can we go from food movement between 132 FIF regions to between over 3,000 counties in the United States over time? So this is the food flow model we developed. As I said, it's a really data-driven framework. The input data we use is the empirical government level collected food movement between FAF zones for different food commodities for once every 5 years. So we use that and we fit a logistic regression model, kind of like a binary decision, whether a distribution link in the network exists or not between the origin and destinations, to kind of mirror the empirical situation, right? So we trained our model on the empirical FAF data, and then we said, okay, these are the links I estimated to find that exist. I did a pretty good job on mimicking the real world network structure. But now I need the capacity of how much food in terms of mass actually moves along those network links. So to do that, then we fit a gamma regression model onto the, again, empirical FAF level data. which then gives us the maximum amount of food that can move along each network link that we estimated to exist. Right. Once we do that, now we have a network of over 9 million links because we're looking at pairwise combination of over 3,000 counties, right? And among those 9 million links, some of them are estimated to exist, some of them are estimated to not exist, but still, that's like a lot of number of links. And probably not realistic for us to expect that a county in Florida will directly send food to a county in Washington state, right? These are perishable goods. Probably the closest regions, if they have the supply, they will probably be the ones to sending out the goods. They're not going to spend days and days in the road, right? So we thought, okay, now among this 9 million possibilities, which one are practically be useful? So we introduce a linear programming to minimize the distance traveled by the food commodities. And then we can also ensure the mass balance. So what is the food being sent out from the counties should be exactly equal to the sum of those counties, should be exactly equal to the FAFSON that encapsulates them, right? We cannot be realistically assigning more than available capacity at the higher resolution to counties. So after that, we were able to actually determine among these 9 million links, we decided which ones will be sending how much food of these perishable goods should be traveling along the shortest distance possible. And that gives us our output, which is the county level food movement data, which is the first in the literature. We run this model individually for 7 different food commodities for 3 years. So we created 21 networks. And then we also, for each year, we looked at if we aggregate all food commodities together and look like this mass movement of food, which gives us another network. And we did this for 3 years. So the first row is what the government reported at the FAF level. How does food move over a decade? And the second row is what we estimated at the county level. And we thought our spatial trend seems to be matching really well with the empirical level. We see that in both cases, Mississippi River, Midwest popping up as the major food transit locations because those are the ones that are mainly supplying the food and sending it to be sent out abroad, right? And we see Florida and California also become pretty important food regions across spatial scales. And we realize that over a decade, the structure doesn't really change that much. So we have a working food distribution system. It seems like we're not changing it that much. Then we also wanted to look at what is the net flow. First row is the empirical data obtained from the government. Second row is what we estimated at the county level over time. If it is darker red, it means that they are supplying more food than they are consuming. So as you can see, Midwest is like the darkest red regions. Those are our production regions for majority of our food commodities. But more urban regions, we can see that they're shaded more blue. So those are the high population centers. So we have more consumption of food in those regions. So they're intaking more than they're supplying. At the county level, we also see this trend to a degree, but majority of the metropolitan areas like Los Angeles, Chicago, New York, Seattle, Houston, the counties that encapsulate those large population areas are all assigned with darker blue shades, which kind of gives us confidence in our estimates because there's no ground truth for food movement at the county level. So this kind of gives us confidence in what we estimated makes sense. And finally, there was a big 2012 Corn Belt drought in the United States. The cereal grain production has been halted drastically, especially in the Midwest. So because of that, we wanted to see change from 2007 to 2012, whether this was captured in our estimates, that impact of the drought. First row, again, empirical data collected by the government. Second row is what we estimated at the county level. Purple means those are the distribution paths or links that observe a decrease in the amount of cereal grain transported. And as you can see, majority of them are accumulated around the Midwest, which is pretty similar to our estimates at the county level. And green means those paths or links actually observed an increase in the amount of cereal grain mass transport in the year 2012 compared to 2007. So then this kind of tells us that whatever was kind of missing in terms of supply in the Midwest was actually picked up by Texas mainly. We see some California participation. We even see some East Coast contribution as well. So again, since we didn't have county level ground truth to compare our estimates and give like a statistical accuracy measure, observing these trends and then being captured in our data gives us confidence on our estimates. Okay, so after we introduced this new network of how food moves between counties in the United States over time, we kind of wanted to see just looking at this data is not enough. We need to take a closer look into it, and can we pinpoint where are the most critical distribution hubs for our food commodities nationwide, right? And which brings us to our second research question: where are the critical locations of agri-food transportation networks? To answer this question, we define what is a choke point or like a bottleneck of food distribution. We determined that locations that are individually has the highest number of connections, locations that are most central in the entire network, and also the locations that if they are not involved in the agri-food distribution, we will be losing a lot of efficiency and resilience in terms of food distribution. So we will be losing a lot of time. The food needs to take longer trips. We assign that could be three different definitions of what is a choke point. So since we have three different definitions, we wanted to introduce a multi-criteria decision-making technique, and we wanted to come up with common locations that are ranked at the top 10 according to these multiple criteria we define to be choke points. And those common locations will be our most critical hubs for food transportation at the national scale. So this is what it looks like for all food commodities aggregated. First figure is FAF level choke points. Second is county level choke points. And this is for if we aggregate all food commodities together. As you can see, majority of them, the counties are kind of encapsulated in the choke points of the FAF level. And these are mainly states or counties, you can say they're more urban, they have more urban characteristics, they have relatively higher GDPs, the population is pretty high, they have international ports in them, which also helps with international trade of food as well. And then we wanted to compare it with the logistics sector revenues at county scale, and we see that they almost like a one-on-one correspondence. So we also say that since we were looking for choke points or transportation hubs for food, our results resembles a lot with logistics sectors that are more dynamic, more active, generates more revenue. So again, it kind of gives us confidence on these locations being more important for nationwide distribution of food commodities. But US is a huge country. Every region has its own different climate, natural resources. So different regions are specialized in producing different type of food commodities. And we thought, based on the regional specialization of food production, this distribution network can change significantly if we're thinking about individual food commodities. So we wanted to identify choke points for different food commodities separately. SCTG1 is live animals. SCTG2 is cereal grains. SCTG3 is fruits and vegetables. SCTG4 is animal feed and products of animal origin, like eggs and honey included. SCTG5 is meat and meat production, meat preparation, I'm sorry. SCTG6 is milled grain goods like pasta. SCTG7 is all other frozen, prepared, processed food. And SCTG all is, if we aggregate all of them, what does it look like? So as you can see, choke points differ a lot by what type of food are you talking about, right? Because different regions are specialized in generating the supply for that good. So where the food originates kind of changes where will be the most critical distribution hub for that food to be distributed within the entire nation. So we wanted to compare processed food versus unprocessed, more raw food commodities, right? What is that? How does that production or supply kind of influence the shape of the distribution network? For the unprocessed food, we choose cereal grains, which are maize, rice, wheat. We see that the choke points at Fairfax County level mainly accumulated around the Midwest, which is also where majority of the agricultural production for the cereal grains occurs. We were kind of surprised to see Idaho there, but then we realized there is a big railroad crossing in Idaho, which kind of connects the East Coast to West Coast. So all the cereal grain moving along through rail kind of makes a connection hub there. So that's why it was popping up as a choke point. And then for the processed food, we choose a CTG7, all processed food together. These are the choke points we identified, which resembles a lot the all CTG aggregated. So these are kind of more in terms of mass, they're kind of determining more on how the aggregated network looks like. And we see that the CTG7 choke points are kind of influence or resemble a lot the food manufacturing industry revenue heat maps in the US. So the darker red is where we will see more active, dynamic, higher revenue generating food processing industry. And then that's again where the processed food is originating from. So that's kind of determining how the rest of the network to distribute these goods to the nation would be shaping up. And of course, finally, since we have data for multiple years, we wanted to see how stable these choke points are. And if it's a darker blue, it means that across 3 years for all the criteria we considered, that location is ranked within top 10 constantly, right? So we see that, well, the choke points we just showed for the most recent data are actually pretty stable. So through the years, we don't see a lot of change in where are the hubs of food distribution within the US, which kind of is a positive finding in terms of policy making, right? So now instead of telling government, oh, it shifts drastically every year, we cannot pinpoint what's the most critical location, you can actually say this is pretty stable. You should make sure that the transportation infrastructure, the logistics sector, or agri-food sector in these locations are very critical for the distribution of food nationwide. In case there is a disruption along one of them, it's not going to be like a local regional problem, but we will be talking about a nationwide food shortage. So make sure you prioritize the security of these locations or the resilience of components of food supply chain, especially in these locations. Okay, but this was all based on the bird's eye view of how the food distribution network looks like, right? And if you want to go and tell the government official or a public policymaker, focus on the food distribution between state A and B, they're not going to be taking us seriously, right? I need some practical, real world, like which highway path are you talking about, or which county specifically? Tell me an exact location, right? So then we thought, okay, how can we map this bird's eye view analysis onto a real world transportation infrastructure? Can we actually pinpoint the highway, railway, and waterway paths that are most critical for the food distribution? Which brings us to our third research question. So here we developed a kind of like a data science, network science, and geographic information science unified framework. We got the shape files of US highways, interstate and state highways, class 1 to 3 railways, and inland waterways. We got the shape files of those, and we converted them into spatially located networks. What we did is every vector link was fully connected vector link was assigned as a network edge, and then the connection point of two edges were assigned as a geocoded network node. So we were able to convert shapefile into a network, and then we were able to map this bird's eye view food movement onto an actual spatially located network of highway, railway, and waterway. But before that, we wanted to take a closer look at what is the government level FAF data looks like if we compare food transportation supported by different modes of infrastructure, and how does it change for different flows of food. Like, is the food for domestic consumption? Are we going to export that food, or are we trying to import that food? That's going to change the load on the transportation infrastructure, right? So we realized that highways are really critical for the food distribution in the US. Someone told me that 65% of the trucks we see on the highways are for food delivery in the US. I haven't been able to find where that data comes from, but I will let you know if I can. But it looks like agnostic to the food type and flow type. Every commodity takes at least one part of their trip along the highways. And what is interesting is that this data only looks at from FAF to FAF distribution. So we do not have last mile or intercity delivery of foods in here. So this is between states almost, how much we rely on highways to distribute our food. But if we think about the bulk movement of cereal grains, we see that railway and waterway is really critical. We also see a CTG3 being really moving in bulk in waterways, which is first we thought interesting because that's like vegetables and fruits. Like, why would we carry them in the waterways? But according to the US Census classification of goods, ACTG3 also includes soybeans. So that big chunk of yellow green we see there moving along the rail and water is actually soybean movement in the US. Okay, and this is what it looks like if we try to look at the combination of transportation mode and different food flow types at FAF level map. For the food that is domestically produced and domestically consumed, we see that highways, railways, and waterways are around the Midwest are accumulating the maximum amount of food transportation. But the food that we would like to export, we see that highways that connect the nation to the port of New Orleans accumulate the highest mass of food. For rail, it is the railroads between Texas, so US and Mexico. And finally, for the waterways, of course, Port of New Orleans. For the food we are trying to import from abroad, we see that highways along the US-Mexico border are accumulating the highest mass, which is where we get majority of our fruits and vegetables in temperature-controlled trucks. So that was something we were kind of anticipating. But for the rail, it is the US and Canada border. We import some grains from Canada through rail. And for the water, the most important, of course, Port of New Orleans was again really important, but the most important one, ports in the California, because we import food from China and that comes into our ports in California. So this was looking at all food mass aggregated at FAF level, but we wanted to look at almost PAT level map. How would it look like? And this is what we computed. So these are all real world highway routes, railway, trucks, water canals, we can travel. And for the food that is being domestically produced and consumed, waterways dominate the transportation, especially the Mississippi River. For the food that is being exported, again, we're kind of finding an alignment with what we find for the aggregated case that highways that connect rest of the US to the port of New Orleans, those are the paths that are doing majority of the food transportation. And finally, for the import, we see highways between US and Mexico border are really critical paths. So since we have different type of transportation modes, and we were thinking about food supply chains, we thought, okay, there are some really common, three most common goals that every supply chain try to achieve, right? Everyone wants to be more cost efficient, everyone wants to be more sustainable, and everyone wants to be more resilient, right? And we thought, how can we kind of see using different type of modes can achieve these goals better, right? Is there a different, and if so, is there one we can pick out or emphasize more? So here we compared how does the cost of food transit versus resilience looks like across modes, and how does the total carbon dioxide emission of food transit looks like compared to resilience of food transportation across modes. For the resilience, we looked at two different characteristics, right? There are many ways we can quantify resilience, but for the transportation infrastructure, we chose these two. Number one is adaptability. How many alternative routes are there? If one of the route is blocked, disrupt, you cannot use it. Can you actually reroute really fast and easily? Are there options, or probably not? This origin and destination is only one way to connect each other, right? If there are more alternative paths, that's a more resilient network, you would say, in case of a disruption. And the other one was diversity, which was kind of looking evenness of contribution. You can have multiple routes, but are these routes kind of carrying similar amounts of the agri-food load, or do we have one path maybe doing 80% of the job, sending food from supply to destination, and rest is not doing that much? Even though there exist alternative paths, if they're not being realistically used, you're still kind of in a vulnerable situation if that one path that does 80% of the job is disrupted, right? So we want to take both into account, and we realized that waterways are really clean and really cheap way of transporting food compared to other two. But it comes with the cost of being really vulnerable against disruptions. We don't have a lot of alternative routes, right? Especially during the impacts of climate change. If the Mississippi River height is decreasing, we don't have a lot of routes to like reroute those large barges to distribute food, right? But on the contrary, truck delivery is the most resilient option. You have multiple alternative routes between any origin and destination. Yes, it can take more time, more money, but still you can deliver the supply to the demand, right? And also, each of these paths kind of carries similar amounts of agri-food, so we don't have like, again, like Mississippi River, that one does almost entirety of the job to send all the supply to all the demand. They're more evenly distributed, but it's really costly, and it emits so much carbon dioxide, not just to travel the distance, but also to temperature control inside of the truck, right? But we realized that railways are actually kind of like a really happy medium. And we realized that railways are actually able to connect all the states or the FAF regions to each other. But they're not being that heavily operationalized. I believe we kind of attended a workshop. We had some people who were working on the railways, food distribution in railways, and we were thinking, how can we increase the role of rail for food delivery in the U.S.? And they were saying, that's a really privatized industry. As a government, we cannot tell them to do anything. We cannot tell them to open up a new railroad or introduce a new fancier rail truck. That was kind of sad, but I think that's another future study that I would like to explore, like how realistically can we increase the contribution of rail for food delivery in the US, because we will be saving from cost and of carbon emission without compromising our resilience so much. So these are the studies that I had done so far, but currently what I'm working on at the US level is what are the high resolution correspondence between food consumption, food waste and food insecurity? Is there like an inequity and unfair access to food in the same geographic regions? And then I'm trying to kind of take into more detailed understanding. Can we find what are the supply chain pathways? Can we, not just for spatial regions, but from actually the farm to the processing plant to the consumption, can we actually create that map of food movement? And finally, I would like to see the impacts of COVID-19 on our food supply chains. How does it vary across different supply chain entities and for different states? How does it look like? And for the global food supply chain, right now I'm working on identifying what are the historical supplier selection trends for grain imports of low-income and food deficit nations. Do we see a good diversification through time or across exporters, or they kind of do the same thing over and over again? Would that put them in a more vulnerable state? Can we predict who would be the future leading nations of agri-food exports? And finally, how can we assess the risk dynamics of grain imports for the importers collectively at the global scale or for individual importers? How would it vary? Yes, this is all I have. Thank you so much for your attention, and I'm happy to answer any questions.
We have some time for questions. So if you have any questions, just raise your hand and I can pass the mic along.
Really interesting work. So
Thank
thank you. On your future work, I'm just wondering if you've, I know you work with Megan, who I know very well. And so do you interact with the people at GTAP and Purdue? Because they do a lot of this food trade work and resilience and stuff like that. I don't know if you, like Tom Hurdle and that group.
No, not yet. No.
Yeah, 'cause maybe I would talk afterwards because they have some good papers on COVID and stuff like that.
Oh yeah,
Yeah.
I saw a couple of them.
Yeah.
I remember some of them were more like egg sector specific. I remember that was kind of giving me the inspiration, but I was trying to see if we can do it for all food, all sectors, all together. But yeah, I would like
I
to
could talk to you
more.
afterwards.
Yeah,
Yeah,
that
okay,
would be
that's
great.
good.
Thank you.
Thank you. Yeah, thanks for the presentation. Very interesting. So I have a couple of questions, if I may. One is just to understand a little bit more as to how you got the county scale maps. So my understanding, you showed one slide where you're getting the national data, which is at a coastal scale, and then doing regression to kind of interpolate or to get it at the county level.
So yeah, so in that one, what we were doing was we were using a regression function at the food flow information between FAF regions, right? And then we were trying to, through variable selection, we were trying to see how can we increase our accuracy to kind of mirror this FAF level information, right? So our training data was kind of where we were testing our accuracy, because at the county level we didn't have the ground truth, and the FAF level data was, there weren't a lot of entries, so we were not able to divide it between training and test data. So the entire FAF level information, that's where we were running our regression, and through variable selection trying to get the highest accuracy where we can mimic this existence of links. We know how we can get that, and our assumption was that across spatial scales this regression function should hold. Only thing for between county movement I need to do is change the value of the variable from FAF to county specific information.
Okay, no, that's helpful, and I'll look at your papers also. But so I presume you could do an uncertainty evaluation, things like that, also, for the model.
Right. I think we did a comparison with, there was another paper who was trying to find the cereal grain movement at the county level, but again they didn't have a ground truth, they just did their own estimations, and we compared our county level findings with that in a previous paper where we did it just for 1 year, and then we kind of extended the model so that it can be more generalizable through year. But yes, we did some uncertainty and sensitivity analysis with another model findings. And there was MITRE group, I think they're also doing some research on the county level food estimation. They had their own models. They didn't share with us, but we presented our results to them, and they said their results were pretty close to what we were getting. But since no one had the ground truth, we were just comparing what our models estimated.
Okay. So one more question, if I may. From an application point of view, so one thing that a lot of industries are pledging to do is to meet goals like net zero emissions and so on. So do you see ways by which your work could be used to guide industry to transition into meeting that pledge?
Definitely. I think it can definitely be one work we extended, which has been published recently. We were trying to optimize cereal grain movement so that we would minimize our carbon dioxide emission. So if we know the supply and demand and we know which are the available paths, how can we optimize which path needs to be taken and how much cereal grain should move along that, and how can we differentiate across highways, railways, and waterways? We kind of did that study. It was again at national spatial resolution, but if a company level data is available, that model can be easily implemented to that. Oh, yes, sorry.
Hi, Denise. Thank
Hi.
you so much. This was fascinating, and I'm a certified fangirl of the food flows work, so it's nice to meet you. I'm curious. I've looked at using the FAF data in the past, and one of the things that I find so frustrating to answer questions about food access is that what you're seeing in these flows is a mix of things at different stages of the value chain, and also things that might be things that consumers would eat directly versus things that need to go through a processing step. Have you thought at all about how you can disaggregate these like gross commodity groups into things that are more useful for understanding the consumer side of things?
That's a great question. And one of the frustrations we had during the county food flow modeling, we were not able to tell food moving from A to B, whether it is just like for consumption, fully consumption, or would it be making a stop at B and then actually being redirected to C. We were not able to disaggregate that in that model. That's why I was kind of hoping this work would be able to figure that out. If we can kind of disaggregate into what is the movement from production to processing and then processing to consumption, maybe I can disaggregate in more detail and give more information at the consumer side. That was one of the issues I'm still trying to figure out, but in the previous work, we were not able to differentiate among those. Another thing was also the food groups are kind of like not that disaggregated as well. So far what we have been doing is we were looking at the origin of the flow, and we were trying to break it down. The production percentage of the commodities can be a good ratio of how the flows are disaggregated. Right, we did it for the cereal grain paper I just mentioned. Since we were looking at just cereal grains, it was easier to break it down, but we were looking if production of cereal grains in Alabama 80% is corn, then I would assume all the flow originating from Alabama FAF zone, 80% of that mass is probably corn. The rest are whatever their production percentages. So far, that's what we have been, how we were trying to figure that out. Yes. Hi.
Just a quick question. There we go. Are you doing any work with the USDA Agricultural Marketing Service?
No, not right now.
But they have a division on transportation in the marketing service, and they do a lot of reports on rail in particular.
Mm-hmm.
And I know when I was there last, we were doing a lot of work trying to figure out how could we rebuild short rail in this country to help support local and regional food systems. But they give out, they do, individual cooperative agreements with researchers on questions of interest to AMS. And with the downsizing of the federal workforce, I know it's a crazy time to be talking about anything grant-wise federally, but they're going to need to continue work in that division. So I would urge you to look at the Agricultural Marketing Service, the Transportation Division. You'll find all kinds of resources there.
Thank you so much. Yeah, I really appreciate it. I think last year, someone in the Department of Homeland Security, they were really interested in how rail supports our food distribution. And they were really interested in extending this mapping to individual foods at rail in a higher resolution. We were kind of in the talks with it, but then they were not able to support university research anymore, so that had to come to stop. But great to hear that there are other organizations who are interested. I'll definitely check it out. Thank you. Yes.
Thank you, Denise. That's really fascinating work. So I'm going to ask more about rail. What I was thinking as I saw your graphs and is time in transit. Like
Right.
product, and so some products are going to be more perishable than others. There's going to be more storable commodities versus those that, even with refrigeration, that there's issues of like time in literal transit, but then there's also the problems of connection from the terminal rail node, which they inevitably then need ground transit to get it to final use. And so I'm sort of curious, do you have information on that? The sort of temporal dimension. I didn't see that. I saw carbon. I saw, but what do you have there?
Yeah, so that's a great question. So far, we only looked at distance. We didn't look at the duration while comparing like the total cost and emission. We only did it based on distance. And right, distance is not as good of an indicator to compare highway and rail than duration. One study, no, I don't think that's going to answer that question. So for that, yeah, that was a different thing. I'm sorry. Well, for one study, we only tried to look at how the cold chain movement looks like at the highways. And in that one, we compared distance versus duration, and our results were pretty similar, but it was only for highways. We didn't do it for rail, but we thought if we do it for rail, it's going to be really different compared to highways. But one thing we were thinking for the serial paper, we just thought serial can go along any mode, right? We don't need temperature control. We don't need any of like duration is not that big of a concern. So that's why switching across modes, how to minimize the distance or emission, we only did it for serial. We first started with can we do it for all commodities, but we were not able to. Like, you have to force some commodities to go through highways, and then in that case you don't get that big trade-off of emission versus resilience. One thing we were thinking, if we can model it as an interdependent infrastructure where maybe in this one, yeah, maybe we can map it as like an interdependent infrastructure where you have some routes from major stations that you're using rail, but that destination station has a immediate connection to highways, and the second part of the trip goes through highways. If we can model it as interdependent, then we were thinking now we can more realistically think about the duration, and then we can actually get better optimization of how should we reroute. Right, we haven't done that yet, but we were thinking that could be a way to how to solve that issue. Yeah.
So we are all, it seems, fascinated by the rail. So I was particularly struck by your comment about rail being more the privatized part, and so less room for intervention by the government. And there are other parts of the world where the picture is completely reversed. For example, I come from India, where railway has been government dominated and has a long legacy of colonial, the colonial legacy, where the British in particular were very focused on using the rail network for connecting production to consumption centers because of the fear of food insecurity, famines, basically. And so we have a rail-dominated food system. But the criticism there has been that the commuter traffic has been an issue, because if you think about it holistically while planning your transportation, you have to think about commuter needs as well as the food needs. And so in that, I just thought that that was an interesting comparison. So we have highways meeting more in the private sector and meeting more commuter needs. Because the railways could not do it, because the railways are so structured on meeting major production centers with consumption centers. So I thought that was an interesting comparison.
Yeah, definitely. That's really interesting. When we were looking at the rail data for the US, the shape files, we were able to differentiate between Amtrak, which is, I believe, for the commuter, versus class 1 to 3 rail. So these are the only ones that US using only for the freight, not for any commuter. But we still realize that we have a good connection. I even tried to look at it at the county scale, and almost all the counties where we were able to connect with rail to a degree, maybe not within the entire county, we were able to make good trips, but we were able to connect almost every country to each other through rail as well. But again, people were like, we cannot tell them to do anything. Right now they're already like removing some of the tracks that are not being used so frequently, like, but you're trying to say, no, we should do more tracks, connect more. We don't have that power, was what the response I generally got. Yeah.
Hello. Hi, everybody. So I want to ask a slightly different question. So right now we're on your last slide, your next step slide, you had it looking at international, right? So right now we're going through sort of a forced international change with the tariffs that are going on, but we also have sustainability forced international change, right? With climate change and whatnot. I'm wondering if you have any thinking and insights on how your work gives us potential insight into the role of transportation systems as buffers or lagging, things that we need to think of. So I'm kind of curious as to how your work can inform us in terms of either these the sort of man-made economic perturbations like a tariff, or global perturbations, and how does that all play out in the context of your work?
That's a great question. I think some of it was coming into play for the first question that I was trying to answer. I was seeing some really big reliance on only a certain countries. For example, Mexico and Japan really relies on their US for their maize imports. Like almost 80-90% of their imports come from the US for maize. And with the tariffs, I was thinking that's going to be a big issue, especially for Mexico, if we're thinking more lower income countries who might not be able to pay such huge tariffs. But then I was thinking, what is the other option? It's like the transportation the infrastructure. Distance is so short, right? So economically efficient, and also in terms of carbon, rather than getting it from somewhere else, getting it directly from US is probably will be the most sustainable option for them for environmental sustainability. But tariffs will make it really hard for them to continue that relationship. So I haven't particularly looked how can we like buffer those two, but it was something that was coming up a lot when I was looking at these historic trends that we were seeing and how it would probably change with the tariffs and more environmental sustainable concerns, what would be the alternative to for them to turn to? I don't have an answer right now, but yeah, some of the results were making me and think about how can we answer those questions.
Great. Any other questions? Perfect.
Just a resource. I'm just an old person. I know all these little things. So the World Outlook Board that USDA does, they do a lot of projections, and they're also, I mean, they're closed down now, but they also do projections about what we might see in a changing tariff landscape. That's a great resource for you and can help you access it if you stop by.
Thank you. Yeah, thank you so much. Yeah, definitely.
One more question. This was fantastic, and thank you so much, everyone, for the great questions. And looking forward to seeing you in 2 weeks for Kelly. Kelly will be presenting.
Thank you so much. I really appreciate it. Thank you for the invite.
Thanks so much, Lenny. This was great. Yes, so much for the invite. I really appreciate it. Sorry for the thank you so much. Oh, thank you. Oh, yeah.